In this fourth class of Chapter 6 of the course of Basic Geometry, I present the following regular polygons: Decagon, Pentagon, Heptagon. In this first slide of this fourth class of Chapter 6 of this Basic Geometry course, it's presented figure 6.16, which shows a polygon regular decagon that's composed of 10 sides. This polygon has the side dimension equal to 0.618 multiplied by the value of the radius dimension. As was shown in Chapter 4, which was referred to the quadrilaterals, in the case of the calculation of the golden rectangle, it was presented straight line segment that composes one of the sides as the value of 0.618 of the value that composes the other straight line segment of the golden rectangle. Thus, the construction used to obtain the dimension of the lateral segment of the polygon decagon is the same one that was present for the construction of the golden rectangle in Chapter 4. Thus, the process is initiated with the drawing of the circumscribed circumference and the drawing of the radius AB, which is the base of the golden rectangle. Then, at point B, a perpendicular is drawn. The segment BC drawn at the continuation has the dimension equal to the half of the value of the straight line segment that composes the radius AB. In this slide, the process for construction of the regular polygon decagon is continued. The figure 6.16 is displayed again. From point C, the straight line segment connecting point C to point A is drawn. We center at the point C and use the radius CB. An arc is drawn starting at the point B and ending at the point D. We center at the point A and radius AD, the arc ND and its station NE is drawn. By definition of the gold segment, the NA line is the gold segment of the straight line segment AB and has the same dimension, that is 0.618 of the dimension value of the straight line segment AB, which is the radius. Thus, the side of the polygon decagon has the value 0.618 multiplied by the dimension of the radius of the circumscribed circumference, that is the straight line segment NA, that has the same dimension of straight line segment AE, that is the side of the polygon. This slide continues to display the properties of the polygon decagon regular. The figure 6.16 is displayed again. Thus, the straight line segment AE is the side of the polygon decagon regular. Drawing the perpendicular bisector of the segment of the straight line AE, that is the side of the polygon, you have the segment of straight line A, that is the bottom. Therefore, a right triangle formed by the radius by the middle of the segment AE, that is the side, and by the bottom. Using the Pythagoras theorem, in this right triangle, you have the dimension of hypotenuse, that is the radius, and the value of the dimension of the leg that has the value equal to the half of the side. Then it's possible to calculate the value of the dimension of the other leg, that is the bottom. Thus, the bottom has the value of 0.951 multiplied by the value of the radius. Knowing the values of the side and the bottom, it's possible to calculate the values of the other entities, such as area and perimeter. This slide shows the polygon pentagon regular, which is the regular polygon of 5 sides. Figure 6.17 shows the circumscribed circumference and the complete construction of a decagon. Using straight line segments, are drawn lines joining alternated vertices of the regular polygon decagon. Thus, you have the polygon pentagon regular that has half the number of sides of the decagon. Observing the triangle BFM and applying the theorem of Pythagoras, we will have that the square of half of the side of the regular polygon pentagon is equal to the square of the value of the radius minus the square of the value of the bottom of the pentagon. Observing the FME triangle and applying the Pythagoras theorem, we will have that the square of the half of the side of the pentagon is equal to the square of the side of the dodecagon minus the square of the straight line segment ME. Making the calculation, we have that the bottom of the pentagon has a value 0.809 multiplied by the dimension of the radius, and the side of the pentagon has a value 1.176 multiplied by the dimension of the radius. Knowing the dimension of the side of the polygon pentagon regular and the value of the bottom, it is possible to calculate the values of the other entities such as area and perimeter. This slide will present the construction and the characteristics of the polygon heptagon regular that has 7 sides. Figure 6.18 shows the construction of the polygon heptagon regular that uses a construction method that is not precise. Initially, the circumscribed circumference is drawn. A vertical diameter is then drawn in the circumference. A horizontal cm radius is also drawn. Centered at the point M, the arc ACJ is drawn by determining the point A and J. A straight line segment AJ is now drawn, which defines the point K in the straight line segment CM. We center at point A is drawn the arc KB, marking the point B in the circumference. The straight line segment AB is the side of the heptagon. In this slide, the remaining characteristics of the regular heptagon polygon are shown. A perpendicular straight line segment is drawn through the midpoint of the straight line segment AB. The straight line segment also passes through the center of the circumference, that is, the perpendicular bisector of the straight line segment AB, which is the straight line segment A, is the bottom of the side of the pentagon. As the construction method is not accurate, it is necessary to use the sine and cosine values of the mid-angle of the center angle, that is 360 divided by 14, to calculate the exact values of the bottom and other entities.